Hi, dear students. Today we will start with a new topic that is balancing of radial engine. Balancing of inline engine we have discussed in previous lecture, and now we are going to study the balancing of radial engines and its definition, then procedure for solving the balancing problems in multi-cylinder radial engine using direct crank and reverse crank method. See, there are different methods for solving the balancing problems in multi-cylinder radial engine. Of this, your syllabus textbook has followed the direct crank and reverse crank method for the solution of the radial engine. So I am also following the same method so that you can solve the problems and refer the textbook easily. Okay, so let's move. Multi-cylinder engine, according to the arrangement of the cylinders, have classified into three. That is inline engine, radial engine, V type. Of this inline engine you have studied, we are moving on to now on to radial engine. So what is a radial engine? See, this is the animation showing the working of a radial engine. As you see, radial engine have radial engine is a multi-cylinder engine which have pistons, different pistons arranged radially in a circle, arranged radially in a circle about the crank center. About the crank center. This is the crank center. See, this is the crank center, and this is the crank, and all the cylinder have the same crank. This is the specialty of the radial engine. There is only single crank for all the pistons, and see, this is the connecting rod, this is the connecting rods, and line of stroke, only line of stroke of the this engine is arranged in a angular manner. Don't confuse that all the piston have different cranks. There is only one crank, and the line of stroke is different for different engines, and it is invented by Jacob Elhammer in 1903. First, and he was the first to build the world first air cooled radial engine, and that was a three-cylinder engine which he used as a basis for a more powerful five-cylinder engine model that was built at 1907. Okay, and see, this is the first air cooled radial engine, and it is very difficult to cool this engine using air, and it is most commonly used in aeroplane because in that case it is easier for this engine to cool. But in case of four wheelers and two wheelers, it is very difficult to cool this engine, and its size is um, heavier than that of the multi-cylinder inline engine. What is the advantages is that um, the speed range for the radial engine is high than the multi-cylinder inline engine. So these can be used without a power transmission system. That is very useful to reduce the weight a in case of aeroplanes. That's why it is most commonly used in aeroplanes and not commonly used in four-cylinder engine. Okay, now that's all for the introduction. Now we will move on to the next topic, that is interval between the line of stroke. See, in case of multi-cylinder engine, we have find the crank angle, difference between crank angle. But here, this is not the difference between crank angles. This is the difference between the line of stroke of each cylinder, and this is fine using this equation, that is angle for cycle of operation. Angle for cycle of operation is 2 pi, and 2 pi divided by n, number of cylinder n, small n, Then you get this equation to find the interval between line of stroke. If three if it is a three cylinder engine, then 360 divided by 3 is equal to 120 degree. Okay, so 120 degree is the angle between line of stroke for a three cylinder radial engine. Okay, and now we want to solve the balancing problems of these radial engines. For solving the balancing problems of radial engine, we use this method, direct crank and reverse crank method. Okay, first we discuss about primary direct crank and primary reverse crank. The word primary is given considering or for pointing out the primary force. Okay, so primary direct crank. Let's see what is a primary direct crank. See, this is the figure. This is the figure for showing the primary direct crank and primary reverse crank. What is a direct primary direct crank? Primary direct crank is a crank which rotates in the same direction of that of the real crank. Okay, and reverse crank is a primary reverse crank is a crank which rotate with the same angular velocity but in opposite direction that of the real crank. Okay, and why we are assuming this, that I will tell you now. See, you have already studied the primary force is equal to mr omega square cos theta. Primary unbalanced force due to the reciprocating mass along the line of stroke is equal to mr omega square cos theta. And by assuming a direct crank and reverse crank and placing a mass equal to m by 2, placing a mass equal to m by 2 at the end of direct crank and at the end of reverse crank, of assuming a mass of m by 2 at the end of direct crank and reverse crank, at the end of direct crank and reverse crank, we can solve this problem. See, what will be the force? See, what will be the centrifugal force if we place a mass at this point? See, centrifugal force is equal to m by 2 r omega square, isn't it? And by resolving along the line of stroke, you will get m by 2 r omega square, m by 2 r omega square cos theta, isn't it? Resolving here, you will get m by 2 r omega square cos theta due to the mass, half the mass, reciprocating mass at the end of the primary direct crank, and due to the mass at primary reverse crank, you get, and resolving along the line of stroke, you get m by 2 r omega square. And by summing these two components, by summing this component along the line of stroke, you will get mr omega square cos theta. Okay, so by assuming this mass at direct crank and reverse crank, you will get a total unbalanced force is equal to mr omega square cos theta. So by using this, you can problems solve problems with for multi-cylinder engines which have common crank. For a radial engine and V-type engine, all the cylinders have the same crank. Hence, we can solve those type of problems using this direct crank and reverse crank method. Now we have considered only the primary, and now we will move on to the secondary crank. See, for secondary here, this is the direct and reverse crank for secondary force. Okay, and what is the secondary direct crank? Secondary direct crank is an imaginary crank which rotates twice the speed of the actual crank in the same direction. Okay, and Secondary reverse crank is a imaginary crank which rotate twice the angular velocity in opposite direction of the real crank, and angle with the line of stroke is twice the crank angle 2 theta. Okay, and this radius is equal to r by 4n, r by 4n. Here crank radius is equal to r by 4n, and mass is equal to m by 2, where m is the reciprocating mass. And by assuming this, you will get, see, you will get m by 2. You know the secondary force is equal to m r by 4n 2 omega whole square cos theta. And by assuming a mass m by 2, you get the, and resolving through the line of stroke, you get m by 2 r by 4n 2 omega whole square cos theta in the direction of line of stroke, and m by 2 r by 4n 2 omega whole square cos theta due to this mass at reverse crank. Okay, and by summing these two components, you will get m by 4 and 2 omega whole square cos theta. Okay, I think you have got an idea, and this is very easy if you solve the problem in next video. Okay, so don't worry about this complexity in this direct crank and reverse crank I have described now. It is actually very easy, and it is very easy to solve once you have solved a problem. Okay, so today you have studied the what is a radial engine and procedure for solving balancing problems in multi-cylinder radial engine using direct crank and reverse crank method. Okay, the problem will be solved in next video. Till then, bye. Thank you.